Hello class, welcome to one of the homework videos. So we're going to go over the 2.2 homework from Savas. So let's look at the first question. What is the student's error in the following diagram? So basically you have, looks like the student's reasoning here for the problem. It says, given that angle 1 is congruent to angle 2, by the vertical angles theorem, angle 1 is congruent to angle 3. So by the transitive property, angle 2 is congruent to angle 3. By the converse of the corresponding angles theorem, A is parallel to B. So first off, angle 1 is congruent to angle 2, so which that is what is given in the problem based off of these two angles. Those are equivalent to each other. They are congruent. And so it says here, angle 1 is congruent to angle 3 by vertical angles. So angle 1 and angle 3 are vertical angles because they are opposite of each other and they're formed by two intersecting lines. So that is true. So those are vertical angles. So that checks out. This checks out. That's given. And so now it says angle 1 is congruent to angle 3. So by the transitive property, angle 2 has to be congruent to angle 3. So basically it's saying that if 1 is equal to 2 and 1 is equal to 3, then 2 is equal to 3. And that is the transitive property. That is correct. So if 1 is 2, 1 is 3, then 2 has to be equal to 3. So that makes sense. Now, by the converse of the corresponding angles theorem, A is parallel to B. And so they're saying that, basically, they're saying that angle 2 and angle 3 are corresponding angles. That's what they're saying. So if you look at angle 2 and angle 3, those two guys, are they corresponding angles? Well, corresponding angles, remember, are would be, for example, if you had these two parallel lines, you have a transversal, and I purposely drew it so it looks similar to this diagram. And if you had angle 2 here, then angle 3, the angle that would be, in this case corresponding, would be this angle right here. And so notice that this looks nothing like that because you have this other line crossing here, right? And they're saying that this is the corresponding angle to that, and that is incorrect. According to this diagram, it would be down here. This would be the corresponding angle to angle 2. So which in this diagram would be this angle right here, right? So this is the corresponding angle in the diagram, not this angle. And so they're using the wrong theorem here. These are not actually corresponding angles. So the error here was that angle 2 and angle 3 are not corresponding angles. And so the flaw in the logic falls short here. Now, with the given information, can it be determined that M is parallel to N? If yes, state the theorem that is used. So they're saying that these two angles, and I'll use a different color here, these two angles are the same. That's what it's saying. And so what are these two angles? Well, these are alternate exterior angles because notice that they're on the outside. This is on the outside. Remember that this right here, this right here is the inside. Everything else is on the outside. So they're on the outside and they switch sides from left to right and from above to below. And so they're alternate exterior angles. And by the converse of the alternate exterior angles theorem, that means that M has to be parallel to N. And so yes, they are parallel by the converse of the alternate exterior angles theorem. And that's a 2.2 question. So now in this example, these are all similar types of examples here. They're asking which lines are parallel. Same reasoning here, but different kind of angles. So now we're looking at these two angles. What kind of angles are those angles? Well, they're corresponding angles because they're both to the right and they're both below their respective lines. I can literally take this angle and slide it down. It's the same exact angle, right? And so these are corresponding. And therefore, by the converse of the corresponding angles theorem, well then these two lines have to be parallel. Which lines? This line and this line. Those are the only ones that proves are parallel. And so the lines that are parallel are MF and HN. Because you don't even need this line on the left side. You don't need that line, so we're ignoring that. MF and HN are what we want to prove, or MH and FN is what they use, or no, MF and HN. So MF and HN. So MF is parallel to HN by the converse of the corresponding angles theorem. So we're looking at that one. Even though it says select all that apply, there's only one choice here. In the given figure, which lines are parallel? Justify your answer. Same deal. So these two angles are alternate interior angles. They're on the inside of the sandwich in our analogy, right? They're on the inside. And they switch sides from left to right, from above to below. So they're alternate interior. And because they're the same, that means that HC is parallel to ND. And by the converse of the alternate interior angles theorem. So HC is parallel to ND. So we're looking at answer choice this example. All right, in the given figure, which lines or segments are parallel? Justify your answer. So we know here that this and this are the same. Okay, so basically we have this line right here and this line right here. If we extend it, we have those two parallel lines. We quote unquote parallel. We don't know that they're parallel yet. And then we have this transversal here. Well, then it says here that if these two are the same, then the lines in red, and I'll use a different color here, then the lines in orange are parallel, as long as those two purple ones are the same. Now, those two purple ones are actually alternate exterior angles. They're alternate exterior angles because they're on the outside. In this case, the sandwich in our analogy is between the orange. And so between the orange is the inside, and so we're clearly on the outside here. And so that means that that means that the orange lines are parallel, which means that I guess you could say HK is parallel to AB in our example. And so those are rays, notice, but we're not concerned with that. What we want to know is, okay, which ones are parallel? Well, according to this, we want something to do with HK and something to do with AB or BA. So we're looking at those two examples. So it's saying that those two line segments are parallel by the converse of the alternate exterior angles theorem. So we're looking at C. All right, so now with the given information, can it be determined that M is parallel to N? Write yes or no. If yes, state the theorem that is used. So it says that the measure of angle 1 plus the measure of angle 2 is 180. So it's saying that they're supplementary by the definition of supplementary angles. And so, well, is that really true here? Well, if you look at this, this is our sandwich in our example. The transversal or toothpick. Well, then these are clearly inside the sandwich, right? So they're clearly inside. And so they are interior, and they're same side interior angles. And remember, same side interior angles do add up to 180. They're supplementary. And so if they add up to 180, that means that these lines are parallel. The purple ones are parallel. And so yes, that is true. The lines are parallel by the converse of the same side interior angles postulate. Okay, find the value of x for which M is parallel to N. And so we have our diagram here. So we want M to be parallel to N. So if we want those to be parallel, well, then that means that these two angles, whatever they are, have to follow some kind of relationship. Well, these are alternate exterior angles. And what do we know about alternate exterior angles? Well, alternate exterior angles have to be congruent if the lines are parallel, which we want them to be parallel, and so they have to be the same. So that means that 3x minus 30 has to equal 2x plus 33. They have to be congruent. The measures have to be the same, so they're equal to each other, and then we can solve. So we're going to solve this by subtracting 2x on both sides. So we have x minus 30 equals 33. Now we're going to add 33 to both sides to cancel this. I'm sorry, I said 33. I meant 30, not 33. The negative 30 and the 30 cancel. We have x equals 63. So that's what my x has to be in order for this relationship to hold where the lines are parallel. If x were not equal to 63, then these lines will no longer be parallel. So we're going to go ahead and type in the value of x is 63. Just type that into Savas. All right, next question. In order for C to be parallel to D, how must angle 2 and angle 7 be related? How must angle 3 and angle 5 be related? Okay, so if we're looking at C being parallel to D, so we're concerned with C being parallel, and so we're looking at angle 2 and angle 7. So if you're looking at angle 2 and angle 7, so these two angles right here, well, then in that case, if we have those two angles, well, these are exterior angles. First off, they're completely exterior. They're not inside sandwich. They're actually on the outside, but they're on the same side. So these are technically same side exterior, but we never talked about same side exterior, right? We only talked about alternate exterior. So what about same side exterior? Well, we can kind of figure this out because, well, we know that whatever angle 2 is, well, angle 4 has to be the same, right? So basically, if we knew that angle 2 were to be 30 degrees, for example, then angle 4 would have to be the same angle. Angle 4 would have to be 30 degrees because of vertical angles. They're vertical. Also, because we know that this is 30, well, then we know that this right here is 30 because of alternate interior angles. Alternate interior angles are the same. And so then if I know that this is 30 and this is 30, we can just go straight to this result by saying, well, these are corresponding, so they're also equal to each other. And so that's how you can go straight from there to there. So they can't be equal to each other here because we have the corresponding angles here are the same. And so therefore angle 7 is not the same thing because it's different. So what are these angles add up to? Well, remember, these two angles, 30 degrees and angle 7, actually form a linear pair. A linear pair is when you have a line, basically you have two lines that cross each other, right? And then so basically they share a side, and here this is angle 7 here on one side, this is 30 degrees on the other side. So here they share a side, they're next to each other, right, on the other side of this line that they share, and they add up to 180 because they add up to a straight line, and so they have to add up to 180. So this is what we call a linear pair. A linear pair adds up to 180 degrees. And so if this is 30, well, then angle 7 is now 150. 150 plus 30 is 180. So this angle is 150 in this example, if I were to make this as an example. And so clearly they're not the same, but for the purposes of this example, we can see that they are supplementary. They add up to 180. And so angle 2 and angle 7 must be supplementary. Angle 3 and angle 5, on the other hand, let's look at angle 3 and angle 5. So if we just focus on angle 3 and angle 5, these two angles, well, those are alternate interior angles. And so because they switch sides and they're on the inside. So alternate interior angles must be congruent. So this is congruent. So that one was actually pretty straightforward compared to the first one. All right, that's it for that question. So now the next question, which statement must always be true according to this diagram? So we just got to check the ones that are true. So let's look at the first one. If angle 1 is congruent to angle 3, then we can conclude that G is parallel to H. So angle 1 and angle 3. Angle 1 and angle 3, those are same side interior angles. Same side interior angles are not equal. They're not congruent. So this is not true. Remember that same side interior angles add up to 180. So definitely not true. So we are not going to check that one. So no to that one. If angle 2 is congruent to angle 4, then J is parallel to K. Angle 2 is congruent to angle 4, right here. Well, those are alternate interior angles, and alternate interior angles are congruent. And so basically that means that the lines that are parallel are J and K. Those are the lines that indicate that that's parallel. So yes, that is true. J is parallel to K. So we will check that. That is correct. Just to look at the other ones. Angle 1 is congruent to angle 2. angle 1 congruent to angle 2. Those are not congruent. Those are same side interior angles. So if you look at these two lines, here and here, well, those guys are same side interior angles because they're on the inside and they're on the same side of the transversal, the toothpick in our example. This is sort of like a rotated sandwich. It's going vertical instead of horizontal. So they do not add up to, they add up to 180. And then the last one, just to kind of check that off, angle 3 is congruent to angle 4. Similarly, angle 3 and angle 4 are same side interior. So actually, they're same side interior not for this purple one, but they're same side interior for these purple ones. In that case, actually they're not even same side interior for that. Sorry. So these are not actually, that's not actually true. So angle 3 and angle 4, you look at them, looking at the I was looking at the image kind of wrong, so let me do this right here. So we're still using the vertical lines, apologize for that, but this is going to be my transversal. And so angle 3 is congruent to angle 4. That is actually true. Those are corresponding angles and those are congruent. However, does that indicate that J is parallel to K? That is incorrect. That indicates that G is parallel to H. Okay, the fact that these are congruent only indicates that G is parallel to H. It has nothing to do with J and K, because if you think about it, it doesn't even involve the line J in the example. J is not even involved in angles 3 and 4. So that is not true. So just to kind of show you your reasoning for why those other ones are not true. All right, that is it for the homework video, guys. I will see you in the next one for 2.3. So I'll see you then.